Hello, can you hear me? Du-du-du. Let's do a quick explanation. Listen, are you able to hear me right now? Listen, I can go ahead and start explaining the problem. Are you there? Are you listening? Okay. All right, person is fixing their audio. Really should set these things up so that I maybe live in my own server and then people come to me. Hopefully, as time goes along, we'll gain a little bit more momentum. Okay, you can hear me? All right, I guess I'll go ahead. Um, yeah. So the question you sent me was basically saying that there is a person starting at some point. I don't really care what, but whatever their initial position is. So the idea is that it tells you that they're swimming north for a little while. They tell you the amount of time, and they also tell you the speed. So just multiply those together, and you'll be able to get some distance, right? That's going to be your delta y. And then it tells you that they're swimming in the negative x direction as well. So again, you can calculate the delta x pretty easily. And the slightly confusing thing about this problem is that it asks you both for the distance traveled, the amount that he totally swam, and it also asks you for displacement. And if this is your very first time sort of seeing seeing the distinction between the two, you might wonder, wait, are these the same thing? And no, they're not. Because distance traveled is basically just x plus y, the delta x plus delta y, whereas the displacement is going to be the Pythagorean theorem, right? It's going to be x squared plus y squared. Take the square root of that. That's all. Does that explain it?
You hear me?
Hopefully, make it pretty clear.
Yeah, I was able to understand that. Thank you.
Yeah. So if the problem also asks for the position vector of the rocket, both Cartesian coordinates, or I guess the final position. Well, yeah, okay. You can always just figure out what the final position is just by whatever the initial thing here was and subtract x and y from it, or whatever the appropriate changes are. And as for polar coordinates, that's just asking you to sort of get the distance from the origin and also the angle from the origin. All right. Does that answer your question? Okay, very good. I can't hear you at all. No, I have not heard anything from your end whatsoever. Yeah, I think it's probably likely that your microphone isn't set up. In fact, you're also muted. You're muted on Discord as well, which might be the reason. But yeah, it's okay either way. You can always just throw more problems at me. I will be online for a little while and happy to help with just about anything. Okay, problem. So that was problem 3, I guess. And the next one is problem 4. So you're given vectors A. Okay, that's. You're given B, and you're given C and D. And some of them are given in terms of radius and angle, whereas some of them are just given in terms of X and Y. Okay, so give the answers in Cartesian coordinates. Okay, for problems like these, you basically just gotta well, if you're being asked to give it in Cartesian coordinates, the idea here is probably just to convert all the ones that are in polar coordinates into Cartesian. And of course, the way to do that is just remind ourselves that x is equal to r cos theta, and y is equal to r sine theta. So if this is in polar, you can just convert this into Cartesian by just plugging this in for x and this in for y. And at that point, once you reduce everything back to Cartesian coordinates, you can just calculate it like in high school, vector addition. Should be simple enough, I think. Yeah. I guess you should always remind yourself why this is true. But if you have some point here that's like r and theta, well, you can always just draw a right triangle, and this is clearly x is equal to r cos theta, and y is equal to r sine theta. That's all there is. Okay, so you're giving me specific. It seems believable. I don't know the answer off the top of my head, but go calculate it out and double check for yourself. I not in the business of doing individual calculations for individual assignments, but conceptually, this is all you need to know. Yeah, at a glance, though, it seems reasonable. Because like the angle here is between 90 and 180. So you'd expect that to land somewhere sort of roughly in here. So a negative value for x and a positive value for y seems believable. Yeah. So if you're being asked, so parts A and B are pretty easy. They just ask you to add or subtract a few vectors. Part C is tiny bit more complicated. We're asked to do like A plus a half B plus 3C plus D or something like that. Yeah, you just distribute the scalar right into the whatever the vector value is. It distributes exactly like you'd want. So for example, if you had x and y, and you put a 1/2 in front of it, this will just turn into half x, half y. That's all. That's all. Just like you would hope. I guess this is probably a really quiet week because everybody's just finished with midterms. Yeah. Any other problems? Yep, sure. Go ahead. Tell us what you got. Let's take a look. What's next? Okay, a pack of 4 velociraptors. Okay, all right. Have caught a human running through their jungle. To divide up their catch, each one pulls a limb and pulls as hard as it can. Okay, this is a very cute problem. So I guess you have a human. We'll just represent the human as like as just a square maybe. Wow, what a creative problem. So okay, they're being told. So I'm assuming that the positive x direction is angle 0. So it's saying, okay, one of the angles is at 20 degrees or whatever you want to call it. Another one is at some other, and they're giving you the magnitudes as well, but I'm just not bothering to use specific values. Okay, now the third one at roughly the third. Excuse me, I guess there's 2 in the second quadrant. And I guess the idea here is, so this is F1, this is F2, and this is F3. And so you're given F1, F2, and F3, but F4 is unknown. The fact that they tell you that it's stationary, so the sum of all the forces is equal to 0, means that you can figure out what F4 has got to be. If the total force is 0, that basically means that F4 has got to cancel out all the rest. So this is totally doable. And the way I would probably do this is break every single one of these into their x and y components, right? This is, I guess, F1x, F1y, and similarly for F2 and F3. And the idea is that F1x plus F2x, and keep in mind some of these will be negative, right? Because F2x is in the negative x direction, plus F3x plus F4x is equal to 0. You know this, and you know this. You can get them all from trigonometry, so just solve for this. That's all there is to it. And the y works exactly the same. Exactly the same. So once you have F4x and F4y, well, at that point, you can just use trigonometry to figure out what the total F4 is. Right, that's just going to be the Pythagorean theorem. And then figure out what, use more trig to figure out what angle it is with respect to the positive x-axis. Make sense? Should be simple enough. Yeah, the whole idea here is if it's all got to cancel out to be 0, yeah, if it's all got to cancel out to be 0, it should, it tells you all the information you need to know. Yeesh, I'm tired. Yeah, it looks like they're asking for an answer. So while it's easier to solve the problem in x and y coordinates, it looks like it's going to be a lot easier. It looks like it's going to ask for the final answer in terms of magnitude and degrees, essentially polar coordinates. Okay, alrighty then. More questions. What other questions do you have? Okay, what did I do? What else you got for me? Okay, an ice cube is thrown into a very deep incinerator pit. So this is question 6. The time-dependent position of the ice cube is given by some vector. Okay, so we get r of t is equal to some x of t times I hat plus some y of t times j hat. It looks like this particular problem, this is proportional to t, and this one has a t squared term. Okay, the top of the incinerator is at y is equal to 0. Sure. At what time will the cube enter the incinerator? So it's saying the top of the thing is y is equal to 0. So that's basically just saying when is y of t equal to 0, right? So if it's some, just take whatever the expression is for y of t and just set that equal to 0 and solve for t. That's all. And since it's a square, you might have two answers. And if that's the case, I think you just got to choose whatever answer seems more reasonable. You're probably going to end up with a positive and a negative answer. Okay, and at this time, how far in the x direction has the cube gone in meters? So how far in x? Well, I think whatever answer you get for t from part A, so just take the t and just plug that into your x of t, right? And I guess take the difference between when t is equal to 0 and when t is equal to 5, just to figure, t is equal to whatever the t final is when it reaches the incinerator. Just plug those both in and take the difference, right? It's basically tells you what's the starting position and what's the final x position. Now, assuming that the pit is big enough to not interfere with the trajectory, and what are the x and y coordinates of the final position before it is completely melted? Note that the cube takes 8 seconds to melt once it enters the pit. Well, okay. So at that point, I guess you just take whatever t final you had from part A, and you just have to add, 8 seconds or whatever to it to get, I guess, maybe t final 2. In retrospect, maybe t final wasn't the best name for it, but t final is when it enters the incinerator, and t final 2 is 8 seconds later. It's 8 seconds later. So then, yeah, exact same idea. Just plug in t final 2 into your x of t and y of t expressions to figure out its final coordinates. And lastly, convert the position vector of the ice cube when it melts from Cartesian to polar. Okay, so just take whatever your x and y were from part C, or the previous part, so just take that x and y, and then just turn that into a radian and angle. I'm going to assume that you should be reasonably comfortable with that part, so I'm not going to go over it. But yeah, once you break these problems down, I think the only thing harder, maybe the spirit of this problem, is just to it's basically just finding, sort of treating the x and y components independently, because the structure of the problem is asking you to realize that it reaches the incinerator when y is equal to 0, regardless of what x does. And that tells you the time it enters the incinerator. And after that, you can add on 8 seconds to represent that it's going further. So yeah, that's probably all there is. That's probably all there is. Sound good? Anything else? Anything else? Part B again. Let's see, what was it asking? Yeah, this time, how far in the x direction has the cube gone in meters? Yeah, that's basically... Oh, shoot. Well, it's technically asking about distance, but for this particular problem, because x of t happens to be proportional to t, distance and displacement are pretty much the same thing in this case. So yeah, just take x of t final minus x of t initial, or I guess maybe 0, and that just gets you whatever the distance traveled is. Now that wouldn't have worked if this was a t squared term, because you could have a situation where, for example, maybe if it was t squared, maybe it's going this way, this way, this way, and it curves back, right? And then the displacement and the distance traveled are different. But because it's nice and simple and it's only linear with respect to time, that means it's just trucking in one direction. Could be the other direction. I don't know if it's positive or negative, but the fact is it's just one of them and stays consistent. That's the idea. Hope that makes sense. Mm-hmm. 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 Okay, yeah, very good. Sounds good. All right, I guess that's probably all the physics questions we need, at least for the UCI set. Yeah, I guess I'll put it there.